Hello everyone again. This time, let's go ahead and go over the last team problem. So here we go. So let's read it first. The polynomial as follows, with this quadratic, and this quadratic, has 6 complex roots. When these roots are plotted in the complex plane, the points create a convex hexagon with area 72. And we want to find the sum of all possible real values of k. Okay, firstly, we need to see what these roots even are. Fortunately, we have the quadratic formula, and what we can do is basically apply it to each of these polynomials and find the roots. So firstly, we have x squared plus 6x plus 25, and this comes out to -3 plus or minus square root of 36 minus 4 times 25 over 2. Wait, hold on. This is supposed to be a 6, sorry. And this comes out to -3 plus or minus 4i. And then you can do similarly, x squared minus 6x plus 25. Its roots are, this time this is 6. This is plus or minus 36 minus 4 times 25 over 2 equals to 3 plus or minus 4i. And finally, we have x squared plus k. And there are 2 cases. The roots could either be real or imaginary, depending on whether k is positive or negative. If k is greater than 0, then the roots are imaginary and as follows. It would be plus or minus I root k. And if k is less than 0, then the roots are real. And solutions would be plus or minus root negative k. Okay, so those are all of the roots, and we can try plotting them in a complex plane where we have the real and imaginary axes. So these blue points here are these points here. Where this is 4 and -4, this is 3 and -3. And there are 2 cases with our red points. Either k is greater than 0 and the roots are like here, or we have k is negative, in which case I'll denote them using green points like this. So our possible hexagons might look like this, or it might look like the green hexagon like follows. Okay, and these hexagons should have area 72. So let's find the values of k such that these hexagons have the prescribed area. So this red hexagon, let's start with the red hexagon. It's composed of 2 triangles like so, and a rectangle in the middle. The rectangle in the middle has side lengths 8 and 6, making this area 48. And these 2 triangles have bases of 6. So this triangle here has a base of 6 and a height that we would like to find. And if this height is h, then the areas of both of these triangles sum up to 2 times 1/2 6h, or just 6h. And we want this, the combined areas of the 2 triangles and the rectangle to be equal to 72. And now we solve for h. 72 minus 48 is equal to 24. 6h equals 24, so h equals to 4. So this height is 4, so 4 plus 4 is 8. So this point here should be 8. And so our solutions for the case where k is greater than 0 should be 8i and -8i. So k here should be equal to 64. So k equals to 64 in this case. How about in the case where k is negative? Then the roots are real. And similarly, we have this rectangle here with area 48. And this time, the bases of the triangle are 8. And so to find the height, we have 2 times 1/2 times 8 times h this time. And then this is 8h. We add the area of the rectangle, and we want to find the height h such that this is true. So 8h equals 24, h equals to 3 in this case. And so we have this as 3 and then plus 3 more gives us the solution 6 and -6 for the case where k is negative. So these roots here should be equal to plus or minus 6, in which case we have k equals to -36. So those are our two possible values of k. So our answer is the sum of these, 64 plus -36 equals to 28.
Hey, this is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.